Okay, guys, the first thing I want to talk about today is the question, is the COVID-19 behaving like a linear or an exponential function, and what's the difference? If you've been in Algebra 1 this year, then you know that we've studied linear systems, but we've also studied linear equations. A linear equation has a slope and a y-intercept. So an example of a linear relationship would be one where, let's say you start with 3 and you gain 2 each day. So then 3 goes up to 5 and 5 goes up to 7 and 7 goes 3 plus 9. So you're adding 2 every day as we go. That's linear, okay? They're adding the same thing every time. If you graph a linear, zero 3, 1 5, 2 7, 3 9, 4 11, it's a straight line, okay? It is a straight line. It's going up, it's increasing, but it's a straight line. That's what linear is, okay? When we think about something growing or something gaining, that's generally the concept that we think about most often. But we keep hearing them say, flatten the curve, flatten the curve. So I wanted to talk to you about what an exponential function is. A lot of times in Algebra 1, exponential functions aren't covered until the end of the school year. And guess what? We're all over the place. Some people are studying this. Maybe they've already started. Some people were fixing to study it when they got back from spring break. So let's just talk about what exponential means. Exponential would be a situation like, let's say that you start out with $1. And this is on day 1. You have $1. Okay? And this is your money. And it's going to double every day. So on day 2, you're going to have $2. On day 3, you're going to have $4. On day 4, you're going to have $8. On day 5, you're going to have $16. On day 6, you're going to have $32. On day 7, you're going to have $64. On day 8, you're going to have $128. And then it keeps doing that. It's doubling as we go. As you can see, it's growing at a much faster rate once you get beyond those first few days. So, with that little intro, I printed out this table for the COVID-19 cases in Arkansas, and I just want to see what their graph looks like if we graph that. Now, there's something else that I wanted to incorporate in here today, is you can graph this on a graphing calculator. You can also graph it on the Calculator X app on your phone. So I'm going to do both ways here. What I'm going to do is I'm going to put these numbers in a list, and I'm going to let the calculator make the graph, and we're going to look at it. So we're going to start with, I press Stat, and I'm going to go the Edit, I'm going to hit Enter. There's L1. I already put the numbers in this one. And I'm going to go to Edit. And there's L1 over here too. And I'm going, let me press autofocus and see if that'll focus on those things any better. I'm going to put the numbers in there. And I know that y'all are having a hard time seeing that. Let me zoom in a little bit. Let me autofocus again. That's the best I'm going to get, okay? So, in L1, I put the days. And I put all the way down to, we're on, the data I have goes like to day 19. I know we may be past that a little bit, but that's where my data stopped because I know we have 508 cases today. So over here in this, I've got 1 on day 1, and I'm going to go ahead in L2, and I'm going to put the number of cases. Day 1, I had 1 case. And then I'm going to go down in L2. I've already filled out some L1 stuff, so I'm just working on L2 right here. I had 6 cases. And then I had 9. And then 12. See, it's not growing very fast. Part of that is we didn't have testing capabilities, but 16, 22. It was 22 for 2 days because we had no way to test anybody for a little while. 37, and then look what happened, 62. 100. 118. 165. 201. 232. 308. 349. 386. 409. Ooh, back up now. Delete. 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 386. And I better put some numbers over here. This would be 17. And then on 18, after 386 was 409, that was 18. I don't want that showing up on here. No, I knew that would probably happen when I got on this free app, but you just have to tell it to go away. 18 is 386 is 409. 19 is 449. 20 is 508. Okay, so I got my numbers in there. The next thing that you do is you press second y equals, and it says stat plot. And it'll do it on here too. Second y equals, and it takes you to stat plot. Well, what kind of stat do you want? Well, I'm going to go to stat plot 1. And I want you to look, it says L1 and L2. I'm going to hit that, and it says, okay, I want to turn it on. I want it to be scatter plot, and I want my x's to come from L1 and my y's to come from L2. So x's are going to come from L1, y's are going to come from L2, and I'm going to tell this one to do a line on my calculator. And I'm going to hit enter, and I'm going to hit enter here. Or I'm going to hit graph. There's my graph. Okay, and you can see what happens here. You can see that that is not a straight line graph, that is beginning to climb, and that the further we go, it climbs larger and larger. Now let's see over here. I probably need to set my window up. My minimum x value, x's are the days, and my minimum x value needs to be 0. And the maximum x value needs to be, I went up to 20 days, I'm going to put 25. Now y started at 0. And then top number of cases was 508, so I'm going to put 550. And then I'm going to hit graph. Okay? You see that's doing the same thing. I got something in y equals that it's graphing that I need to take out. I need to take that out of y equals. So I'm going to hit graph again. And then on your calculator, on your phone, you got to you can work with it a little bit. But you see it's the same line, right? You see that's the same line. Now when they say they want to flatten that curve, what they want to do is they want it to quit climbing. They want it to level off, and then they want it to start going back down. Okay? So that's what makes it exponential. Now, I always want to know what the equation would be for an exponential function. So this calculator will do that for you. I'm going to do stat, and I'm going to tell it to calculate something for me. And you probably wouldn't be thinking of doing this at home, but I'm telling you that I've done enough problems in higher level math that it'll tell you the exponential function. So I'm going to tell it to run an exponential regression. That means it's going to study those numbers, and it's going to create the best equation possible to match that graph. And where do you want me to look for your x values? In L1, and your y values are in L2. And I want you to calculate it. And there it goes. Instead of y equals mx plus b, it's y equals a times b to the x. A is the amount we start with, and b is the growth factor. So what this looks like is y equals 3.1 times b, which is 1.35 to the x power. So guys, it's not doubling each day. If it were doubling, then it would be a 2 in here. If it were tripling, it would be a 3. If it were staying the same, it'd be a 1. But it's a little bigger than 1. So it's growing at a growth factor rate of about 1.35. Now, I'm going to do that on this on the phone. Let me close that. Let me tell it to stat. Let me tell it to calculate an exponential regression. Okay, let me hit enter. Well, I probably shouldn't have been in y equals when I started that. Let me do second quit. Second clear. Clear. Now let me tell it to stat, calc, exponential regression. Yes, I want you to look at L1 and L2. I want you to calculate it. Upgrade. Purchase the app to do this calculation. Well, you knew it was going to ask me that. That's not going to do everything for free. I'm not purchasing the thing. I don't want you to do it either. But I just wanted y'all to see that that's what it will do for you. I wanted you to see how to use this, and I wanted to talk to you about flattening the curve. Please stay home and wash your hands and do all the things they're asking you to do, because we want this number to get smaller. And as the curve looks now, looks something like this. This is what they're going to tell you when they talk about it peaking. It's going to come up here and it's going to peak, and then we want it to go back down. And when it does this, then we'll get back all together and we'll talk about quadratic functions, because then it will mimic more of maybe a quadratic than an exponential. But as of today, that's what you got. You got your exponential function going on with this corona.